Hello everybody, in this lecture we will be solving 1959 I should say, IMO problem number 1. Here is a view of this problem. We would like to prove that the following fraction is irreducible. It's not possible to further simplify it for every natural number n. Now this is the very first problem of the first International Mathematical Olympiad, and so let's provide two different proofs to that problem. So let's begin by the following. So so this is our first solution. So let D be actually the greatest common divisor of these two expressions in the numerator and the denominator. And given that, now I claim that if D divides both of these expressions in the numerator, of course it would also divide. This would imply D will of course also divide a linear combination of the two. In fact, what I have in mind is 3 times. Of course it would also divide 3 times 14n plus 3 minus 2 times 21n plus 4 as well. But then if you expand these, so we would get 42n minus 42n, these will cancel, so we'll get 9 minus 8, which is simply equal to 1. So what it means is that the greatest common divisor divides 1, but there's only one value which would do that for natural positive integers, and that's D is equal to 1. So this implies that the two expressions on the numerator and denominator are relatively prime, and as such it's not possible to further reduce this given fraction. Now a second solution will directly use the Euclidean algorithm, and so the Euclidean algorithm is just simply a repeated application of the division algorithm. The last remainder not equal to 0 basically gives the greatest common divisor. So let's just solve the problem accordingly then. 21n plus 4, let's first divide it by 14n plus 3 using the division algorithm. We realize we have only one of these, plus the remainder 7n plus 1. And now if you all remember how to proceed next is that we move this one on this side, so 14n plus 3 is equal to, move that one as a divisor, 7n plus 1, and finally we realize this is 2 times with a remainder, so there's a plus 2 here, there's a plus 3 here with a remaining 1. Now finally let's shift the things one more time. So if we shift this one here again, 7n plus 1, we just realize is equal to 1 times 7n plus 1 plus 0. So that's a 0 remainder. So we would like to go the previous step. So here let's go the previous step, and that number here actually turns out to be the greatest common divisor between the two numbers and the original numbers at the beginning, which we decided to call as D. Again, the greatest common divisor is 1, meaning that both of these expressions on the numerator and denominator are relatively prime, and as such it's impossible to further simplify to reduce this fraction for any natural number n. And that solves our problem. Hope you enjoyed it, and looking forward to see you guys in our next lecture.